5 August, in the Greenland Sea between northeast Greenland and Spitsbergen, 1,830 miles of polar ice behind her, Nautilus rides in the sunshine. Her silent radio now cracks out the coded message to the Chief of Naval Operations. Nautilus, 90, north. Off Iceland, Commander Anderson is airlifted to Washington. Nautilus proceeds to her destination, England.
Dateline, Washington. President Eisenhower today awarded the Legion of Merit to Commander William R. Anderson of the United States nuclear-powered submarine Nautilus, which pioneered a submerged sea lane between the eastern and western hemispheres. Also, the Presidential Unit Citation was awarded for the first time in peace to Nautilus and all hands.
New York City, Nautilus is home. After setting a new submerged speed record from Portland, England to New York City, Nautilus is tying up at Brooklyn Navy Yard. Commander Anderson now comes ashore, followed by Admiral Rickover, called the father of the atomic submarine, Secretary of the Navy Gates, and New York City officials who boarded in the harbor. Welcome home. Well done. Broadway, and a hero's welcome for the officers and men of Nautilus. An enthusiastic tribute from a grateful nation. Naval science, nuclear power, inertial navigation, and the courage and spirit of the Navy are making new history even now in the trackless voids beneath the seas.
%80 of the major nuclear weapon systems supporting United States defense depend upon electronic products designed and produced by Autonetics, a division of North American Aviation Incorporated. These products are created, developed, fabricated, and tested here. This is Autonetics' Anaheim complex, the free world's largest single concentration of defense electronics capabilities in one area. In less than a decade, this division grew from a small electromechanical department of North American Aviation to one of the top 10 electronic organizations in the United States. The tall building with a landing port for helicopters on the roof is the new headquarters. More than 20,000 of Autonetics employees work at this site. Modern buildings house the latest manufacturing facilities, machine shops equipped with automated machine tools, electronic assembly areas where components take shape as subsystems, dust-free facilities for the assembly of precision devices, automated functional test equipment, and environmental test facilities. This Scoresby machine duplicates the motions experienced on the sea, while radars are tested in these tracking bays. In the Research and Development Center, Autonetics scientists look to the future, exploring the mysteries of crystal formation, growing crystals, performing studies in pattern recognition, and probing the structure of matter with electronic microscopes, leading into the next generation of microelectronics. These facilities reflect the technical leadership which Autonetics maintains in the electromechanical field. An early major milestone was the development of the X-10 missile for the Navajo program. In the X-10, Autonetics successfully integrated an inertial navigation system, a transistorized computer, and an automatic flight control system. Entirely unmanned, the system took off, flew a supersonic flight under inertial navigation control for several hundred miles, and returned to its point of origin, executing flare-out under automatic airborne control to touchdown. That was in 1953. An inertial platform originally designed for the Navajo missile was adapted to a submarine for marine navigation. This was the Nautilus, first to cruise under the polar ice cap to the North Pole. That was 1958. Today, Autonetics' N7 series of ships' inertial navigation systems constantly determine position, attitude, and alignment reference for Polaris submarines. On patrol, accuracy of these systems has been consistently better than specifications. So has reliability and the time between resets. Performance of Autonetics systems made it possible for the Navy Special Project Office to abandon plans to purchase auxiliary navigation equipment. For air missions, such as the Hound Dog missile and Vigilante attack bomber, the N5 series of inertial platforms was designed and developed. A design milestone was achieved with the platform for the Minuteman I missile. It has only 2 gyros, each of which functions on 2 axes. The newest members of the inertial auto navigator family are the N16s, lightweight inertial navigation systems for high-performance, quick-strike tactical aircraft and other uses. More than a decade of progress tells a similar story in radars. It began with the MG-4, utilized primarily in the F-86K planes in Europe. The NASAR systems, such as this R-14 shown here, undergoing tracking bay tests, brought into being Autonetics multi-mode monopulse radars. U.S. Air Force F-105s are equipped with the R-14. Further advances are being made in another new family of radar systems using microelectronics. Thin film circuits are being used in the R-47 terrain-following radar shown here, and the R-45 multi-mode radar. These systems are designed to be 20 times more reliable than current production radars. They feature small Cassegrainian-type antennas which utilize 2 reflectors. These radars have an all-weather multi-mission flexibility not formerly available in a small system. They contain their own built-in circuitry capabilities to provide self-check and are capable of operating failure-free for more than 2,000 hours. Maintenance problems have been greatly reduced through the use of functional plug-in modules. The thin film circuits are extremely stable and highly reliable, all of which means higher efficiency and less time spent on inspection, adjustment, and checkout. Autonetics established a separate Minuteman division. This special division coordinates all aspects of activity within Autonetics and throughout the country with a supplier complex of 2,600 companies. The Minuteman achievements of all these major systems are due in a large part to Autonetics' philosophy that reliability is a way of life. A philosophy that assures optimum reliability through every phase of the organization's effort, from design through development and production, and throughout the delivered hardware's operational lifetime in the field. Systems engineering establishes the mission requirements, including acquisition cost, maintenance needs, operational availability, and probability of mission success. It considers systems mechanization to meet these objectives, including extensive trade-off studies in size and weight, performance, costs, and of course, reliability. Designs and specifications are written for suppliers, then monitored in their own plants. By standardizing designs and parts, the Minuteman Parts Improvement Program increased the reliability of transistors by a factor of 100. Progress and change go hand in hand. And this is Autonetics, working unceasingly for tomorrow.
On the shores of the western United States, the county of Orange and the city of Anaheim, California, one of the nation's leading corporations is working to provide a more secure and viable America. Within this 225-acre, 3 million square foot aerospace complex, Rockwell's Autonetics Electronic Systems, or AES, boasts some of the world's most advanced technological innovations, with scientific applications in a wide variety of military markets. Over 8,500 people are employed at the Anaheim AES divisions, which include the Autonetics ICBM Systems Division, Marine Systems Division, Sensors and Aircraft Systems Division, and our newest business sector, the Electro-Optical Center. Each of these businesses consistently and efficiently operate at the outer limits of what is possible. Join us now as we review the strengths and accomplishments of AES and put into perspective a broad view of this remarkable organization. Autonetics has a proud history of producing avionics equipment for some of the world's most advanced military aircraft. The Autonetics Sensors and Aircraft Systems Division, or AS and ASD, continues to support the F-111 and B-1B with maintenance systems, modifications, trainers, and spares, while developing advanced avionics for upgrades to U.S. and international aircraft. AS and ASD is also developing advanced avionics that will provide the technical edge in all-weather conditions. Deployed in aircraft, tanks, and missiles, millimeter wave and laser radar sensors used in these systems connect to processors which discriminate threat components from background clutter and help identify target classes. Based on Autonetics' many years of experience, these automatic target recognizers, or ATRs, are the cornerstone of such programs as Startle, which has demonstrated first-round hits on moving tank targets, and MTAS, which can find and destroy targets at night and through smoke, fog, and dust. An additional use of millimeter wave radar was recently successfully tested on FLAG, the Flexible Lightweight Agile Guided Experiment, which made a direct hit on an incoming missile. Rockwell AS and ASD is using advanced artificial intelligence technology to develop expert system maintenance aids that evaluate test information on the flight line, diagnose problems, and determine solutions. The new digital signal transfer unit for the F-111 uses Rockwell very high-speed integrated circuits, which are faster and more reliable. For over 30 years, the Autonetics Marine Systems Division has successfully supplied navigation and shipboard electronic systems to U.S. and Allied naval forces. In the years following the successful design of the ship's inertial navigation system, or SINS, and its installation and operation on board the U.S. Navy's Polaris strategic fleet, Autonetics has developed increasingly sophisticated navigation instruments that have become standard equipment on Navy ships and submarines. A recent innovation, the Ring Laser Gyro Navigator, or RLGN, applies the latest technological advances to meet the Navy's requirements for precision navigation, sensor stabilization, and missile guidance alignment, as well as providing many Air Force guidance and control applications. Responding to the increased need for effective ship's information management systems, Rockwell's AMSD developed the Data Multiplex System, or DMS, which provides rapid, survivable, and easily expandable shipboard information handling. DMS has been operationally evaluated and approved for use in all new DDG-51 class destroyers. In a recently won contract, Rockwell AMSD is leading a team effort to produce a combat system for Australia's new submarine fleet. Rockwell Ship Systems Australia, or RSSA, will maximize local content of their workforce and will eventually install an all-Australian management team. Improvements in Soviet submarine capabilities have propelled anti-submarine warfare into prominence. AMSD's expertise in signal processing, detection, classification, and localization of hostile threats is demonstrated in equipment such as the Fast Time Analyzer System, or FTAS, which is used aboard the U.S. Navy's surface ships and at land-based anti-submarine warfare centers. Also, Rockwell's towed array signal processing equipment for use aboard Trident-class submarines will provide advanced processing, display, and management of acoustic data from a variety of passive sensors. Our fourth and newest business is the Electro-Optical Center. The center's primary products are infrared focal planes, temperature-sensitive eyes which can pinpoint objects from satellites in space, or allow a soldier to see through darkness, fog, and smoke. Anticipating the market for these products, a production facility was established in 1983 by transferring technology from Rockwell Science Center to a military production facility at the Anaheim complex. By the end of this year, the Electro-Optical Center will have delivered focal planes containing over 1 million of the sensitive infrared detector elements. The center is also developing products for programs at several Rockwell divisions, as well as for other government tactical and strategic programs. Ranging from man-portable night sights to satellite, earth, and space surveillance systems, some of our products are used by customers to probe the frontiers of our universe, while others provide the eyes in space to deter our adversaries from considering a surprise attack.
Autonetics Electronic Systems, backed by the significant breadth and depth of the resources of Rockwell International, is eager to tackle tough problems. And we're not resting on our past accomplishments, but rather aggressively applying the right technology to high-quality, best-value solutions for our customers' needs. We're doing this with our most valuable assets, our people. Over 8,500 highly qualified employees steeped in a can-do tradition.
Innovative solutions such as those you have just seen are among the credentials most valued by Rockwell's Autonetics Electronic Systems. Our proud heritage continues to inspire that extra margin of commitment, that dedicated spirit that so many years ago heralded the establishment of our great nation. From From Bunker Hill to Benghazi, America has fought for those principles and freedoms that were forged in the fiery cauldron of conflict. And for over 3 decades, Rockwell's Autonetics has been there, defining